So every week I receive an email from Leetcode called the Leetcode Weekly Digest, and within that email is like articles written on Leetcode's website, or coding challenges, or problems of the week picked for you. And one of those problems recently was the linked list cycle 2. I've done the first linked list cycle, but I guess I didn't do the second one. So, given a linked list, return a node where the cycle begins. If there is no cycle, simply return null. There's a cycle in the linked list if there's some node in the list that can be reached again by continuously following the next pointer. This visual aid kind of, makes it a little bit more clear. 3, 2, 0, -4. -4's next node points to node of 2, which was the second node in the linked list. So we're going to use Java for this one. Let's go ahead and check out the Java collections class. Now we can go ahead and add each node into a list and iterate through the list to detect if we've already reached that node, and kind of manipulate it to kind of figure out if that's where it actually started. But then you got to iterate through the list every single time, through the entire list every single time, just to find that out, and that's very inefficient. So then the list is out of the question. It's very inefficient. So now I'm looking at set, and if you're taking discrete structures or discrete math, which most CS majors will, if not all CS majors, a set is a list of elements, but those elements are unique to that set. There cannot be any duplicates. So for example, if I add 1, 2, 3, 4, 5 initially to the set, and then I want to add 3, that's not legal. That's not what a set is, because every element in a set is unique. There's no duplicates in a set. So the program, in this case Java, it will not let me, and an error will arise if I try adding a element that is already in the set, such as 1, 2, 3, 4, 5. Initially 1, 2, 3, 4, 5, and then I try to add 3, it's gonna throw an error. So we can use set to our advantage for this problem. And we're going to use HashSet. Set is the interface, and HashSet is the subclass that implements the interface. And pretty much a HashSet is a set, except with a HashSet, it uses the hashing function to go ahead and store each element into a table. And hashing is very fast and efficient. So let's see if we can go and solve this linked list cycle 2 problem. So we're going to create a variable called HashSet is equal to new HashSet of type list node, and we also want to create a variable to keep a track of which node we're currently on. So var current node is equal to head. We'll assign it with some data, which is our head node, and we want to start our loop. So while the current node is not equal to null, because if it is, that means there's no cycle, and we just want to return null if there's no cycle detected. Now we just gotta have now we need a condition to detect, if we've arisen to a cycle. So how do we do that? So remember when I said if we try to add a duplicate element into a set, the program is not going to let us. An error may occur. Well, we can take that to our advantage. If we do if and negate the condition, HashSet dot add the current node. So we're going to add the current node we're on, we're going to add it to the hash set, and if it lets me, or if it successfully adds the current node to the hash set, that means there's no duplicates in the hash set. It's a unique element, and the code within the if statement is not going to run. But if we're trying to add the current node and there is that type of node in our hash set, that means there is a duplicate that we're trying to add, and we cannot add a duplicate element to a set. Each element is unique, so therefore it's not going to let us, and the condition will be true in this case since we're negating it, and we want to return current node, which is where the cycle will that's where the cycle begins. And of course we don't want to just be stuck in the head, or this won't solve the problem. So okay, don't put that outside the while loop like I'm doing. I just want that at the end of the while loop. So now we do current node is equal to current node dot next, because we don't just want to be stuck on the head of the linked list. We want to keep going through the linked list so we can actually detect the cycle. So if we run this code, okay, the first test case passes. And there we go. So these attempts where it says C++, I did a first take on this video, and I didn't realize that my compiler was on C++. So that was a big mistake of mine. So I feel like linked list cycle 2 is a very good problem to kind of intuitively learn the set data structure. It's very easy to learn and understand, especially with the context of the problem. So yeah, that is the set and hash set data structure. And that's pretty much it. Thank you guys for watching. Have a nice day.